jet engine works by sucking in large amounts of air, adding energy to it, and then pushing it out the back of the engine. The force that this creates is used to propel the aircraft forward. At high powers, the fan can suck in over a squash court's worth of air every single second. Around 90% of this air is routed straight out of the back of the engine. This is known as the bypass air and provides around 75% of the engine's thrust. The remaining 10% of the air is routed into the engine's core. Here it is mainly used to generate the power to drive the fan. The cold air is compressed by up to 50 times its original size, equivalent to taking a phone box full of air and squashing it down to the size of a small microwave. Simply the act of compressing the air can raise its temperatures to over 700 degrees centigrade. It is at this point that some of the air is routed away from the main gas path and taken to cool the hot components at the back of the engine. Just imagine how high the temperatures can reach in these engines when the cooling air can be this hot. Each turbine blade provides around the equivalent power to 10 small family cars, but the first thing a turbine blade must do is survive. Each blade is being exposed to 18 tons of centrifugal load as it spins at 10,000 revolutions per minute. All of this whilst being exposed to temperatures of over 1600 degrees centigrade. Complex cooling techniques are used to protect the turbine blades from the extreme temperatures. Cooling air is allowed to coat the surface of the blade in order to do this. If the same techniques could be applied to a blade made of ice, it would be able to survive indefinitely in a domestic oven, even at its highest setting. When we looked at the fan, we learnt that 75% of the engine's thrust is provided by the fan's exhaust. So where does the rest of it come from? Well, the remaining hot gas after the final stage of the turbine is allowed to expand at high velocity through the engine's exhaust nozzle, providing 25% of the engine's thrust.